Our next speaker in this conference is Ms. Goda Kumar. She is the EVP of Data Science at Swiggy, and we'll be talking about the Data Science division at Swiggy. She was at Ola for 2 years as a principal data scientist, where she led the machine learning and optimization algorithm behind pricing and matching. She has several publications and presentations in industry journals and academic conferences. Over to you, ma'am.
Hey, thanks for that introduction. Am I audible?
Yes.
Yes. Okay. Hi, everyone. It's lovely to be here. Let me just share my screen. Is it visible?
Yes.
Yes.
Okay. So I think because all of us would be, at least in India, who are from India, are eating out, I think I need not introduce Swiggy. But what I am planning to do today is to go behind the scenes and try to see how data science and AI is playing a role to make that food reach you and get delivered to you, right? So what we will do today is we'll just go over a customer's journey through the Swiggy app. And at each stage, I'll try to throw light on what's happening in the background, right? That's how I've kind of structured today's session. I might take about 20 minutes and then we'll open up to questions. So as soon as you open this, that's the phase or the journey stage of the customer is when the customer is discovering what's out there on Swiggy. It starts with the screen where you say delivering to or locating you, right? It might seem very simple as to maybe there's no AI behind this. It's just about taking my GPS location and locating my address. But if you actually think about that, this itself has a few things running in the background, because a lot of times, the GPS is not accurate. Sometimes people haven't and you're in news every time. So for us to kind of figure out what address to show here itself is kind of an algorithm behind that, trying to figure out, should I look at your favorites, your saved addresses, find the nearest point of interest that's there around that GPS, because here we cannot show the lat long, but you'll actually have to show an address that makes sense to the customer, right? At this page, when we are locating the customer, there are a lot of algorithms of location intelligence, of address mapping, point of interest identification, and snapping the GPS the nearest location that are running behind just in this screen, right? Okay, you get located, then you go to the screen and you see a lot of tempting items over there, or curations of different cuisines and different items. Now, when we think about how this popular curations gets populated, there is a burgeoning field of food intelligence, as we call it. You can think of it like every dish across different restaurants in the country have different preparation styles, different taste profiles which are more localized. Like a biryani in Hyderabad might not be same as a biryani in Chennai, right? And they also have whether they go into the starter or the main course, what time of day is it, and what types of cuisines make sense for that time of day, when is it eaten, right? So think of it like a very hierarchical taxonomy of dishes that you need to have, which is the food intelligence. And every new restaurant that gets onboarded, every dish that comes onto the menu needs to be classified to see where it sits in this whole taxonomy, right? So that's the field of food intelligence that powers this, because to come up with these curations, you not only need to abstract and understand the dish, you also need to understand the taste profile of the customers. When you think of taste profile, this is a very intangible sense in some way. We need to abstract out what the customer might like. You might have had a pizza or a pasta last time, but does that mean you will try something else that's European cuisine this time? So how can we understand the interactions between customers and the dish types they have tried to learn the graph interactions? This is where a lot of, graph neural networks, graph embeddings come into picture for us to be able to kind of map a given customer to what they might like. That is how some of the top picks for you, because that is very personalized for the specific customer, kind of comes into play. And to be able to personalize that, there is a lot happening in the background to understand that abstracted interaction of dishes and customers, right? Please keep logging the questions. So then we go a listing of different restaurants. Maybe you click on a collection or a cuisine type and you get a long list of restaurants. So when we look at it, there are two aspects that are going in here, right? First of all, which restaurants are made available to you, right? It's not just a function of whether the restaurant is open, it's also a function of whether we will be able to serve you from that restaurant, because we need to have delivery partners close by to that, right? So this is almost like fast forwarding a few minutes and mimicking the scenario of, if this customer were to place an order in this restaurant, how well can we deliver it? Because customer will also take some time to go from here to the menu to check out and pay. So there is some time, and within that time, anything can happen, right? So here there are two aspects of defining the delivery scope of every restaurant based on how many delivery partners we have and things like that. But it's also about ranking restaurants right for the specific customer based on their taste preferences, personalized in a manner for that customer, right? So here in the ranking, it's a very interesting problem, because it's not only about the customer, but it is also about some of the business objectives that go hand in hand in terms of how mobilized is the supply around that restaurant. If most customers, let's say, want to order burger from truffles, how do we ensure more and more delivery partners go towards truffles? We can increase the delivery scope of that restaurant, right? So here you see that merging of three different things playing out the role. First of all, determining what kind of delivery experience we can deliver from each customer, ranking them right for every customer, and also mobilizing the supply in a way that it tries to follow the demand in some way, right? Then when it's not only about just going into the listing, every customer sometimes comes in having something very specific in mind, that today I want to eat noodles, right? And then we have to match the search, either the dish or the restaurant, and be able to rank it, which is most relevant for that search phrase that we have. So it's not only about the retrieval mechanism here, but you also need to think of, let's say, what is the hero dish of every restaurant? Because there are many multi-cuisine restaurants. So you may get a Chinese noodles in a multi-cuisine restaurant, you get a Chinese noodles in a Chinese, right? So when the customer is searching for noodles, which one should you rank on the top in the dish search, right? So it has a lot of aspects, not only just about the words that are put in there, but also the context of a semantic nature of the dish that is being searched for, or semantic nature of even the restaurant names itself. There could be multiple restaurants with similar names. Which one do you kind of show up at the top when the customer is searching for it? Then you choose a restaurant, you come to the menu page, right? And here is where I think it's very important for the customer to decide whether I should order or not, because the delivery time is very important. And I think with food delivery, one thing that commonly happens is hungry customers are also a little bit angry customers, right? So you have to promise right and keep the promise as much as possible. So the delivery time that we show at multiple points. So there is a point where in the menu you're showing a delivery time. At that point, we don't even know what the customer is going to order. If the customer orders a very fast item, yeah, we may be able to keep up that promise. But let's say customer orders a different dish, which might take a little longer to prepare. We have to adjust the time and show the right time at the checkout, so that, that's where kind of the contract gets formed with the customer, that this is how much time your order is going to take, and that's what you're paying for, right? So this delivery time prediction across the journey of the customer is a interesting and complex area, I would say, because it's not only that when you're estimating the total delivery time, you need to estimate the preparation time by the dish type, by the restaurant type. the same dish, different restaurants take different amount of time to prepare. The restaurant might have some stress because there are some dine-in customers at the restaurant which we are not aware of, or they may have orders from other platforms, right? So it's a very challenging problem to estimate and you don't even know sometimes what the true prep, because you only know when the delivery partner went there and picked up the order. What if the order was ready much before, right? So it's a very challenging problem to solve, to estimate the preparation time, but it's also about estimating the travel time. How long will you take to find a delivery partner for this order, and how long will that delivery partner take to travel? And here it's the difference between cabs and is that cabs come to the gate, but the delivery person has to go through the gate, enter on my gate, go reach the door and do a door delivery, right? So there is also of last mile of traveling from when you reach the gate to the customer, right? And in different kinds of apartment societies, different kinds of points of interest, that may take different amount of time. So the time prediction part of, you know, just to say, it takes a lot to promise right for the customer. Right? And then once the customer has placed the order, we have this dual path going on. So the order gets relayed to the restaurant starts preparing the food. And meanwhile, in parallel, we are trying to find a delivery partner. The partner travels to the restaurant, waits till the food is ready, and then heads off to the customer, right? So here the most important part, we have so many orders, many delivery partners. How do you exactly which delivery partner should deliver which order, right? So once you have placed order, we are showing some time to the customer, making some assumptions on all of this. Status keeps changing as the restaurant prepares the order, and your time also keeps changing every minute to keep the customer updated and to keep it transparent for the customer. But this whole problem of which delivery partner should take which order, imagine the number of combinations that there can be, because there are many restaurants and each delivery partner is at a different distance from each restaurant. Many restaurants are sharing the delivery partners. Same delivery partner has multiple restaurants they're eligible for. So for this, we almost evaluate more than 4 million combinations within a minute. And for those combinations, we should be able to estimate how much time it's going to take, what kind of delivery experience will be given to the customer, what's the cost of, and you need to take care of many of these objectives. It's like a multi-objective optimization problem that needs to be solved for us to find the right delivery partner. And in some cases, let's say you have more orders and less delivery partners, you might have to send multiple orders with the same delivery partner, but ensuring that it's along the way and there is not much deviation, so that you can save time, and actually that's helping you give a better experience to the customer, and the customer doesn't feel like it's going in a different direction. So that's a very challenging problem altogether, as to how do you find which set of orders to pull together when you have situations where you have more demand than supply. Right? With all these efforts all said and done, right, things do go wrong, like they always do. So that is when the customer reaches out to the customer care saying, where is my order? And here again, the number of agents will be limited, but at the same time, it is best experience possible to the customer. That means if you are not able to have one-on-one, like every agent being available for every customer, there is also a chatbot in between that needs to figure out as much as information as possible, if possible, even resolve the issue for the customer. And only those which don't get resolved kind of come to the agent, right? So there is a lot of natural language processing that's happening at this point to enable the chatbots. And at the same time, once it reaches an agent, let's say some issues are not solved and it has to reach an agent, there's also a matching problem to say which ticket has to be assigned to which agent, who is the right agent to solve it as fast as possible for the customer. How many tickets should we give for each agent simultaneously? Because of that multitasking, we need to ensure it doesn't kind of impact the response time, but at the same time, you have more tickets than agents, and hence you have to, because nobody has infinite resources that way, right? So you will have to balance that concurrency, assign the right tickets to the right agent so that the resolution time is minimized. At the same time, ensure how much of the flow can move to the chatbot so that there is more automated and fast resolution for the customers, right? So I just rush through it very quickly, but that's kind of the journey every customer kind of goes right from the beginning to the end on food. Not to mention, of course, there is grocery, there is Genie, which is the pickup and delivery service, which are slightly different from food. Because when you think about grocery, what is important there is the whole optimization of who should pick the order, how should you pick it, how do you route the picker through the store to pick items quickly and pack them and keep ready before delivery executive comes and picks them up, right? So the whole picking optimization, right packaging for the right order, depending on the volume, it's like a knapsack problem where you try to get as much value stuffed into a bag and the cost of the bag needs to be lesser, right? So there is packaging optimization that comes into play. There is this whole supply chain management and inventory optimization to make sure we have the right availability and the right items stocked at the right stores nearest to the customer to be able to deliver as possible. On pickup and delivery, there is a very interesting thing that you don't know what the task is. Sometimes it is going and picking up medicines. Sometimes it's going and picking up dry clean items. Sometimes it's about going, waiting for a service and getting things back. So there could be multiple kinds of tasks that are there, right? So for that, when you're at least on the food side, you know there is a certain dish and it takes a certain amount of time to get prepared. But these tasks are so varied with very little information from the text that the customer enters as to what the task could be, that you have to estimate what is the service time for each of these at the location. Is it a simple pickup drop, which might just be a minute? Or is it like waiting for a service and collecting certain things? Do you have to make payment? So there are a lot of aspects that play a role in a pickup and drop service like Genie, right? So I guess that kind of gives an overview of what data science at Swiggy could be and what kind of problems might be getting solved in the background. I'm sure next time you're ordering on Swiggy, you'll be able to think that this is what is happening in the background when I'm seeing this on the screen. So I'll just take a pause here for any questions that might be there and any interactions.
Thank you, Ms. Goda, for that. I am also like, I'm going to take like some time to even analyze the kind of things which you rightly said, that, we probably don't understand the things that are happening behind a simple food ordering system. And now that, and you won't imagine, while we were talking, I got a notification from Swiggy right now. And I'm like, okay, so now I'm going to probably think about it every time I order. So a couple of questions that are coming in is one question which says is that can you give us an insight into the tech stack and what algorithms are being used in this particular stack? So that's one question, and then I'll move to the next couple of questions.
Understood. So in terms of so there are two aspects. If I'm data science side of things, because algorithms are spread across operations research, traditional machine learning, and deep learning. For example, the dispatch or the matching that I was talking of are all like mixed integer linear programs where you need powerful solvers to solve optimization problems, like you need Gurobi, or sometimes we use different solvers there. On the machine learning side, for most of the time prediction side, we are more on the TensorFlow side. Deep learning models are what are being used. But some of the problems are more simpler, where even a traditional machine learning model can solve for it. Mostly Spark MD is what we use to deploy these models. So we have an in-house data science platform which makes because most of these models are real-time models, right? So taking these models to production and ensuring there is a decent latency and throughput of these models is a big challenge, And to make it as self-serve as possible, that the data scientists themselves can go and put these models to production, we have an in-house platform that we have kind of built to serve these different kind of models, open up an API around the model, and serve. I'm not sure if that's what you were referring to as back. Mostly, like most data scientists, write code in Python, Spark, and the team also does.
Sure. I think that definitely was helpful in understanding the tech side of Swiggy. Another question is Swiggy working on predicting which consumers would demand what kind of food on a given date? Also, is there any plan to integrate with different kind of databases that are available? For example, the national database, or like ABHA, or to advise the health suitable food ingredients?
Right. So there is active work happening on the food intelligence side, like I mentioned. So that uses both public sources available of dishes, recipes, preparation styles, as well as a lot of internal annotated data, crowdsourced data. There's a knowledge graph that's being built on the food taxonomy. So there is a lot of work gone on dishes very closely, right? Food. There's also a blog, I think, on this. So a lot of machine learning on that knowledge graph applies to, so that as and when we get new dishes, we are able to classify and say this is this kind of a dish. Because certain times, let's say ice creams, you need to be able to send it as quickly as possible. That you can do only if you identify it's an ice cream and it has a very low shelf life, right? So yeah, so in that aspect, both public as well as internal annotated data sources are used. What was the second part of the question? I forgot, sorry.
Is we planning on integrating with any national databases, the food related databases, in order to predict what their consumers will demand in a better fashion?
Not exactly national food databases, but we do have a lot of study on the healthy food side of things, like the health hub. Some people might have seen that showing up, which had a lot of hard work gone into getting the details. That I think we're getting the details of calories that are there, what is the protein content that is there in every, so that we can also show it up as part of the health hub for very health conscious customers. And also it created a new category for us as well, to kind of show it to as a separate, like who are health conscious will directly go and click there and go and order from there. So in that aspect, yes, there were some databases used to get the healthy ingredients kind of aspects for health hub. Yes.
Noted. The next question. Oh, so we have a bunch of questions coming in and flowing. So the next question says that does the Swiggy system take care of weather conditions while showing the delivery time and the food menu options? Like, for example, on a rainy day, the suggestions that we're getting are these hot piping pakoras, and then probably in summertime we're getting some, ice creams and shakes and so on and so forth.
Yes. So I would say it's a combination of AI and HI both. Right. When I say HI, it's human intelligence. Right. So as far as the weather thing goes, we do have sources of weather data that we collect, both for us to know, because it's an effort for the delivery partner to go in rain and deliver the order. So we also need to kind of compensate the delivery partner accordingly. So for that purpose, we do collect weather data, as well as to be able to estimate that there will be a delay or the delivery time it might take because of rains. You also might have seen a message on the tracking screen saying it's raining, and you might see some clouds and all of that. That's coming because of this weather data source. As far as recommendations and personalization of dishes go, so there is an aspect of the customer, the time of the day and things like that, but there's also a lot of human intelligence that has gone into creating curated collections that make sense by time of day and by type of customer, by region as well. So I would say it's a combination of both AI and HI there.
Thank you. The last question for today is, and this is a personal question coming in from me, I just want to understand what's the next big thing that Swiggy is kind of, working on or doing with respect to, because, honestly, that we've been seeing that you guys have, really tried to personalize our experience. So what's the one thing that, that's been being worked on with respect to personalizing or increasing the customer delight or customer satisfaction part?
I think Swiggy's mission is to deliver unparalleled convenience, and convenience does not only mean food, right? It's at least our dream is to say from the time you wake up in the morning till the night, whatever needs you have, we need to grow to a level where we can cater to every one of them. I think we are launching a lot of, in smaller initiatives where we are trying to see this Swiggy minis. If you want to go out and dine, the Swiggy dine out. So we are trying to increase our breadth of coverage in terms of just making sure every point in your life is convenient. I think we went into grocery and then pick up delivery, and I do imagine a day when all you need is Swiggy from morning to night.
We hope that they come soon. And in the interest of time, there are certain more questions which we'll probably email it to you so that you can then answer them. And then we can then personally send these answers to our audience. But thank you again, Ms. Goda. I think this was a very, very personally also a very insightful session. And it really helped us, basic things that we do on daily basis, and we don't even think about, what goes behind it and the mammoth of data that, we're generating, and you guys are helping us. You're helping tracking and using tools to, make our experience better. So thank you again for joining us today. And it was truly a very, very inspiring and insightful session. So thank you again.